All right, hopefully this is working well. Give it a moment for everything to populate up here. Give it some time for people to hop in. See how this all goes. Hopefully everything sounds good. I don't have a way to check on my end, I don't believe. Just mute things. Maybe I can look. I think I have everything all good, so hopefully you guys can hear me okay. Gonna be taking a look at particle attraction, my video that came out today. If you haven't watched it, we have a video that came out today on particle attraction to the surface of other objects. I'm going to be kind of going over that a little bit further. I'm going to be trying something. I don't know if this is going to work at all, to be honest with you. I'm going to try to blend some particles, or blend the attraction between objects. So we'll see how that goes. Not sure if that will work very well or not. Honestly, not even sure how I'm going to go about that, but we'll kind of figure it out as we go here. Give a few minutes for people to join up in case they are interested. If anybody's in here, if you want to take a look, let me know how the sound is. Make sure everything's okay. Take a brief look. It looks like everything should be okay, but just want to make sure. If you guys can give me some feedback. Just a moment, we will jump on in. All right. Go ahead, I'm going to create a geometry node here to start off with. And we're just going to take a couple of different objects. Let's maybe move them in space. Let's translate it. Let's just go to the side, I suppose. So we'll start off with the pig head. I'm also going to maybe look at a rubber toy. And I don't know that I want to merge them. Let's template this. Let's move this over as well. Let's maybe drop a match size down for this pig head as well, just so it is more centered. And I'm going to actually have to change that. Let's see. This is kind of a bigger object. I don't want to scale that down like that. Let's scale this down a little bit here. And maybe we'll just set this to min before we move this over in the X. So we'll start with something like this. Let's create a sphere just as something to create some points on. And I'm going to template this match size actually. So what I'm kind of looking to do is I'm gonna spawn these particles on this sphere. We're gonna attract it to the surface of this pig head, and then we are going to kind of move them over to the rubber toy. So let's scale up this polygon mesh. Let's actually set this to a polygon, and maybe I'll give a mountain as well. Just crank up some of these settings, give it some different shape to it. And I'm going to move this over as well. I want these to kind of be engulfed, or this pig head to be engulfed inside of this object. So maybe we'll take a look here. Oops. It's not the right hotkey. That's what I was looking for. Okay, so I'm gonna move this a little bit more. And that'll probably be good, I guess. Maybe I'll scale this up just a little bit more. I don't want to scale up too much because I don't want this to actually take forever to get these particles moving in. Let's drop down a pop net here. I'm going to use that sphere as our first input. I'm going to use our pig head as the second and this rubber toy as the third. And I think I can untemplate that now. So let's take a look at this pop net here. So I don't want a ton of particles spawning, so let's just turn that off and set our impulse activation to that $FF equals 1. Just create that first frame and maybe create like 3,000 particles. Create our pop attract. And again, set this to our surface points. And this is all just basically what I covered in the video today. So if you haven't checked that out, kind of goes into the theory of this. I am going to make a separate video on this, kind of attracting it to the surface with kind of a minimum distance type thing set up. So we'll take a look at that, like I said, in a future video here. But let's set this up for now. We're going to use our second context geometry. That was our pig head. And then we want to randomize some things here. So let's see, how do I want to do this? Do I want to set this as a minimum distance or just random? Let's just start out with a random, I guess. So let's set up this pass through. We'll take our goal prim. And if you guys have any questions, feel free to stab me in the chat and I can kind of go over things if you have questions. But we need to generate these random, the randomness to where the prims are, or what prim we want to attract to. So we can use, it needs to be an integer and an integer. So if we take a look at our primitive here, this little parameter is called the goal prim. That is going to be a integer, as you can see here. So 0, 1, 2, 3, 4, whatever integer that we have. And actually I need to, let's see, I'm going to need to create, I'm going to need to find the maximum number of primitives here. So that's not what I want. 2885. All right, so we need to do an attribute promote. I don't remember if this will work or not. Let's take the primitive. I don't know if we can take a primnum. I don't know if that'll work. Make this a detail. And we want to take the maximum. Does that work? No, point number. That does not work. Let's see. We need to find the maximum number of primitives. So I know I think there's a function for this in Vex. Let me take a look. Just so we can Google this real quick. Houdini. Let's see. Vex max prim, or number of prims. Is there a primnum function? I know there's a like a max point number. Let's see. It's not what I was looking for. Max prim. Prims in one node. Let's see if this gives us what we're looking for. N primitives vex function. That's what I was looking for. All right, so we can do this with vex. So let's just do an attribute wrangle. And then we'll just do this as a detail. And we want, let's call this n prim. Let's go I at nprem is equal to, and that was, let's see, n primitives vex function. So n primitives, awesome. I need to give it anything. Geometry should be 0. And that should give us what we're looking for. No. M primitives detail. This is not working. Primitives, let's see. I don't know why that doesn't work for a detail. Remember, that doesn't make any sense. All right, we'll leave it as on our primitives there, and then we can just attribute promote that. So attribute promote, do primitives, and we want nprem, and we'll call this, we'll make this a detail, and we'll just make that maximum, whatever. Shouldn't make a difference. Point to number. Why is this still not working? 285. I have a million. What is going on here? Why do I have a million detail attributes here? I have something checked on that I'm not. Is this intrinsics? Do I have intrinsics turned on and I'm not realizing it? I do. How do I turn these off again? I don't even remember. View, let's see. I change this. I know I set this up recently and I don't remember what I did. I don't want the point number. Change from nope, that's not what I wanted. Why am I drawing a blank on this? Let's see. View. I don't know what is going on here. It still doesn't make any sense why this would not be promoting. So it's still not giving me my number of primitives. Let's call this, or maybe this is just on. If you know in the chat how to turn off this just intrinsic, I can't remember how to do this. Let's see. I changed it recently and I don't remember how to do that. Geometry, spreadsheet, turn off intrinsics. That's not what I was looking for. I thought it was just this view thing. Why? Definitely don't. I don't know why. I don't want that point attribute. I don't know why I'm not getting my number of primitives here. And this is just looking weird. I don't know what's. I should not have 10 million friggin' detail attributes. I guess these just create a ton. Because I've not really paid attention to that. Why are you not promoting my number of primitives? Let's change it so it works for that, but it just doesn't promote to detail. That makes zero sense. Let's call this, I don't know, test. Still doesn't give me anything. That is dumb. Why does this not give me a detail attribute? It should be promoting. I got the names right. That doesn't make any sense because it's promoting it to other classes. Let me just clean this so I don't have all this garbage and still nothing. Okay. All right. Well, let's just ignore that, I guess. And we will access it from the primitives. Oops. All right. Let's dive back into this popnet here. Am I dumb? Am I? You're right. It is the far right, isn't it? I am so dumb. Okay. Sorry. I'm. Yeah, you are absolutely correct. I don't know why I was thinking that. Just freaking tired, I guess. You're right. So we'll set our number of primitives back to that. I do that a lot actually with the, because that's the vertex one. I always think of the vertex one is the detail one. I don't know why. Thank you, Matt. I appreciate it. I'm just dumb. And is this always set to intrinsics? I don't even remember. I know I changed this recently, but I don't remember if that's what it normally is for this view. Anyways, let's dive into here and let's take a look at this. So our pop attract, let's see, let's do our floor because this has to be an integer. Get back on track here. Thank you, Matt. I don't know why I was thinking that. It's not a mistake that I normally make. Just a little tired, I guess. Anyways, so floor, and then we can do our fit01 with a random based off of our pt num. And let's fit that from 0 to, see, we want to access that detail attribute. So detail. Can we do, okay, yeah, so second input would be 1. Hopefully this works. String attribute name, integer. So we call that nprem. And then first value, is that right? Let me, yeah, that should work. And then let's see, where am I at? Should be all we need. Does that work? Nope. Unexpected. Oh, I had the wrong parenthesis there. Back to our scene view and let's take a look. Let's see if this does it. That's not what I'm looking for. We need to do our collision detect. Take a look at that. So again, I want to set this to first context geometry. Don't need to accumulate hits. Turn off that color because I don't care about the color, and then we'll have them stop. Let's see. First context, accumulate. I guess we don't need that, do we? So let's see, what am I forgetting about? Why is this not attracting? We do want to group those two. We'll call this, let's call this final pause or initial pause. I don't know, whatever. It's not working. Oops. All right, what am I doing wrong now? It should be working. I don't know why my collision's not working. Second context. Yeah, I'm dumb. Second context geometry. There we go. So now we have somewhat of a randomness, and this is part of the problem that I have with the pop attract. It seems to just clump. And actually, let me just set this to dark. So it seems to clump kind of in the vicinity of the first primitive, because if I take a look at our pig head here and I turn on point or primnums, I thought maybe it's not around the first prim 0, but it does seem to just kind of group around certain primitives, which I don't really know why, and it's kind of hard to get rid of that. So we will have to randomize that somewhat. Let's see. We can do this with our XYZ distance. So we'll do a pop wrangle, and I'll set this up here. So these XYZ distance function for this, we need a couple of things for this. We need an integer. We'll call it my goal prim. We need a float, so we'll call this goal dist. And we need a vector, my goal prim UV. Let me just pop this out. Can I make this text bigger as well? I think there is a way to make the text bigger with a vex. Vex make text bigger. I think there's a hotkey for it. Forget. That's not what I was looking for. If you know I think there is a hotkey to make vex text bigger. I don't know, bigger text. Vex editor font size. This is kind of what I was looking for. Control plus. That's what I was looking for. There we go. I knew there was a hotkey to make the text larger. So just so it's a little bit easier to see. So we need to take this and then we need to set, let's see, our goal prim. I might load up my old project to see. Because I forget. Let me do that. Launch another instance of Houdini here. I've been playing around with this so much recently. I should have this memorized by now, but I don't, unfortunately. So take a look at the actual project file from the video today, and I can reference back to that for this. All right, so I have like 5 different setups in here. I'll go over kind of one of them. So this is kind of what I was looking for. The final prim. That's not actually, that one's not what I was looking for. So there's different methods to do this. I went through a bunch of them in the project file. There's different methods that give you different types of results to the attraction to the surface. So some of them work better than others. This is one of them. That's using some interesting methods here. I've got, let's see, this one, I guess this one's just using the random position. I'm not actually using the vex. Let's hop back to the start for this one. So this one, pretty much the same. I think they start to slow down. This might be the one with vex in it. Yeah, so this one's based off of vex. And then I guess I have a pop speed limit in here, but I did this without, I guess I didn't include that in this file, but I had another one set up where I used the distance, the goal distance, so how far away from the surface it is, to actually slow down the particle. So maybe we'll cover that here in a bit. But Jose, hello from Venezuela. Hello from the US. So let's see, I basically need to recreate this. So I can kind of do the same thing. So I don't want to just copy this. Maybe let me bring up a notepad. I'll copy this over for the moment. Just pull that off screen just for my reference here. So we need to set a value. We can kind of set whatever we want, or like an attribute. Can kind of create whatever we want, but the goal prim, and actually I guess we'll do this. I'll create a separate integer. We'll call this the final pause integer, or attribute, and then we're going to use that as what we're going to be setting. So I at final pause, we'll set that equal to, again, we need to make this an integer, so we'll need to use the floor function. This is going to round down any integer that we have. So 2.99 would round down to 2 instead of rounding up to 3. So just keep that in mind as you're using the floor function. So then we can use our xyz distance function to kind of create this. So we'll reference our pig head with that 1. The first input's going to be our spawn geometry, so the sphere that we created with the kind of randomized or the mountain node on it. And then we need to take in our position that we currently have, and then we want to write to these primitives that we created, or these attributes that we created. And these don't actually have to be attributes. You can use just the what's the word I'm looking for, like variables. You can just make them variables if you want, but I make them attributes so I can see and kind of debug a little bit easier. You can take a look in the geometry spreadsheet. We can actually take a look at these. So we need to write to these. So we'll do at my goal prim. So this is what it takes. It needs to, the goal prim and then our goal prim UV. So my goal prim UV. And we should be good with that. And then we need to just calculate our goal distance. We may, like I said, we may use this here in a minute. So we'll do f at goal dist, and we'll set that equal to basically the same thing that we did right here. So we'll just copy this on over. And I'll cover this kind of more in depth in a video, or just kind of explain it better in a video, break it down. So that'll be coming soon, probably next week. So keep an eye out for that if you want more information on this. I'll probably cover a couple of the setups from the project file that is available on Patreon if you guys want to grab that. But take a look here at the final thing, which would be setting the primitive UV space. So, and actually, why don't I just pull up this project file real quick. So if you didn't watch the video today, the way this works is essentially we need to set a UV space for this, as well as the primitive number. So in this example, I've just got a grid with 4 different primitives here, and I have set a random goal primitive. So it's basically overriding this value right here. So a random goal primitive between 0 and 3. This says 4. So remember, this is going to round down with the floor function. So we're going to fit a random value from 0 to 0 to 4, and then it's gonna round that down. So if we take our goal prim UV, this is just setting it to 0.5. So we could overwrite this if we wanted to and create a vector and just set it equal to whatever we want. But if I go ahead and play this, you're going to see that it's going to send this to the center of each one of these primitives. So let's turn off that grid as well, so it'll be easier to see. So it's sending it to the center of each grid because the starting points, if I take a look at the point numbers here, well, I guess of our grid. So this is point 0, 1, 2, or 1, whatever, 3 and 4. But 0, so our UV space is going to go from 0 to 1 in the U or V, whatever one this is, and then the other one will be 0 to 1 in this. So the center will obviously be the center here, but if we were to crank this all the way up to a value of 1, it would move it over to this point right here for that specific primitive. And we can randomize that within. So we could create a random vector, and if we set that equal to our goal prim, then these points would be spread out kind of throughout this primitive. So that's essentially all that we're doing inside of this function that we're about to make, or this attribute that we're about to make. So we'll call this, I don't know, we'll call this one v at goal or final prim UV. So I find it better to actually create these attributes and then set them in the pop attract, because the pop attract tends to kind of overwrite the values, even if it's just like a pass through. It's the way, at least my basic understanding of it, is that the pop attract is going to calculate itself last, and if the pass through just, I don't know, it just doesn't seem to work as well. So it kind of wants to use these values even if you have already set the goal prim UV or the primitive UV. I feel like that's kind of why you get some clumping. I could be completely wrong at that, but with what I've been playing around with, that seems to be kind of what's happening, or at least that's the way it seems. So we'll do our v at final prim UV, and we'll set that equal to the prim UV of our second input, so each of our primitives from our pig head, and we'll use our position, if I can type, and then we need to use the goal prims that we set up here as inputs. So at my goal prim and at my goal prim UV. And that should be good. So let's see, with our pop attract, we don't necessarily want to do this anymore, and let's shrink that back down a little bit. So we don't necessarily want this. We want to set this equal now to the final position. So we'll do, make sure we specify whether it's an integer. So I at final pause, and hopefully we'll get something that we're looking for. And then v at, what did I do? Final prim UV. Is that what I did in our wrangle? Yeah, final prim UV, yes. So hopefully this should work now. And we're getting something weird. Looks like it is partially working. Kind of. Not really sure what's going on here. So let's see. I probably typed something in wrong here. Maybe, let's see. We'll just reset this back. Diagnose what's going on. is it just attracting towards the center all of a sudden? Let's take a look at our geometry here. So our final pause. Well, that's kind of why it's creating this value, which is not at all what I'm looking for. Let's see. Final prem UV, is this even updating? It is not. That is a great question. I have not seen this happening. Take a look back at this. Oh, I think I know what I did. Okay, so important note on this. Primitive wrangle, we actually have to come into our inputs, and our input one is, or our input one would be our initial geometry. So we need to set input to our second context geometry, and then I'll just set this up for later because we're gonna basically copy this over. So that should fix our issue there. Now I can read in the primitive and everything that we had, and we get something a little bit different here. And we can come back into our pop track. Let's just copy this and paste that on over. And let's see what we get here. So I may need some sub steps or something in order to get this to calculate right. I don't know why our... Okay, so let's not do it that way then. Let's go ahead and, I don't want to really mess with this. Let's just get rid of this pop collision detect, and let's create a group here. Oops, and we'll call this, what did I call this in my examples here? Final pause. We'll just do that same thing here. So final pause. Need to change the bindings of the wrangle maybe. Yes, Matt, you were correct. That is exactly what I needed to do. I always forget that step when I'm putting in the wrangles inside the pops. Definitely easy to overlook there. But we need to take another wrangle in here, so pop wrangle. And then we're going to be looking for this final, or the goal distance that we set here. So we'll do if at goal dist is less than, let's do like 0.01. Then let's go ahead and let me pop this back out. Just be a little bit easier to see for everybody. So one thing I wish Houdini would do is not synchronize the scale of this with this. That'd be really nice to be able to break that. Probably a lot easier said than done, but that'd be nice if I could do that. But anyway, so if we want to do this, we want to set our v at v, so our velocity equal to, and I don't remember if I can explicitly state this or not. Let's see, is that going to throw a fit? Maybe. And then we also want to set our group, so I at group underscore final pause. Set that equal to 1. And we want to set this equal to everything besides that group that we just created. And let's see, hopefully that works. Let's see. We also want to do it for this, right? Nope. Let's take a look back in here. Pop wrangle So let's see, final pause, tract. So I'm not sure what's going on here. Let's see. Don't need that actually. Final pause. I'm not enabling it by default, so we should be okay there. Add goal list. Tract. Why am I no longer getting that movement? Let's see, what am I missing? I'm missing something simple and stupid. I know. Goes to 1. Pause. I'm missing whatever it is. Pop a tract. Huh. Oh, the joys of Houdini. Group. Why? Okay, let's look at our spreadsheet here. So everything. I don't want everything in that group. What's our goal distance right now? So, oh, did I set it to greater than? I bet you that's what it did. Goal distance. Yeah. Sorry. I'm an idiot. So just flip those. And now we should have, yeah. So we're still going to have some of the same issues here because the substeps are not enough. It's not calculating this value, or it's moving past this value too quickly. So if we want to slow this down as it starts to get closer, we can run it through another wrangle. Let's see, I'll just put that there. So if at goal distance is less than, I don't know, let's do like 1.5. So if it's less than 1.5, then we're going to take the velocity, so v at v, and then times equals, let's see if we can just type this out. So we'll do 0.95, 0.95, and 0.95. Are you going to throw a fit when I do that? So it should slowly start to bring it down there. And that may be not enough slowing. Actually, we could, at that point, just bring back our collision detect just to clean up any sort of issues that we have there. That way we don't have to crank up the sub steps. And let's click stop. And that should be fine. I want to group these. Actually, it won't matter because they'll automatically get put in that group. Hello. What is your name? Bondell. Welcome. We're working on this effect here, which still is not working correctly. It seems like these particles are passing through. Yeah, they're passing through. Why are you passing through? I wonder if that has anything to do with the normals of the eyeball. Let's just get rid of the shader real quick. Or is this an open hole? No, it's not an open hole. So let's see. For the solver, let's see. Collisions tolerance 001. Maybe drop that down. Nope, still getting that issue. Okay, so I thought that would have solved the issue. we could do a merge, and then we can bring in a static object, I guess. And let's convert this to volume VDB from polygons. 008. 05. Bring that closer. Okay, that should be fine. And then we can pipe this into a null as well. And we'll do out collision or out pig head. Collision. Sure. And then hopefully this should clear up those issues that we're having with this passing through. Let's turn off any sort of bounce. And let's see, we need to set our object. And I also want to turn that off because I don't want to see that. And we're still getting those collisions, so that doesn't make any sense. Let's see. I'll set that to force volumes. Not really sure why these particles are continuing to move past their issues. Do I do live streams now? I've got a little bit of time tonight, so I am live streaming tonight, but probably not going to be a regular thing just because normally I don't have the time, but I did for tonight, so figured I would hop on here. Let's add some pop wind. I don't know why this is not stopping once it gets within there. Maybe actually before I do that, let's crank up our threshold. Let's see if that fixes it. So it should be colliding with the geometry no matter what, and it should be stopping those particles. Okay, that did the trick there. Maybe let's get rid of that too and just see if it still does that. Okay, so that got rid of the issue that we're having with those particles continuing to move. And do we even need the collision detect? We'll just check to see. No, we don't. So we'll just go ahead and delete this stuff for now and add it back if we need it later, but this should be fine. Do I sound okay? I don't know what I sound like. It's the first time I'm streaming on YouTube, so hopefully the sound's okay. Looks like on my end it's showing that it should be good, so hopefully everything is all good on your guys' end as well, and we're not getting a bunch of like artifacts on the stream as well, because the particles tend to do that type of stuff, sort of like grass in video games if you're just streaming video games, but hopefully that quality isn't too bad. Sounds good. Thank you. Okay, so we have basically the setup that we're looking for here. Let's add in our pop wind, and we'll crank up some amplitude here. Maybe we'll crank up the swirl size as well, and we want to come into our attract and just make sure that we increase that force scale a little bit. And we can crank this quite a bit up because as the particles start to get closer towards our object, we are going to have them slow down. Now you're seeing some interesting effect here going on. That's because we haven't enabled this pop wind specifically for the particles that have not stopped. So if we enable our final position group there, sorry, we want to do the opposite of that. We want particles that are not in that group. Got any sneak peeks to upcoming tutorials? Well, you're looking at it, I guess. I don't know if this is going to work. Essentially what I'm building towards right now is a blend between objects here. So we're getting the initial thing set up here with the particles moving towards our initial object, and then we're going to have them move towards our rubber toy that we have set up over here. At least that's the goal anyways. No idea if this is going to work. I haven't tried this before. So we'll see kind of how it works go through. Also, this is kind of a follow-up is to the video that I posted today about the pop attract. So if you guys aren't aware, I posted a video on that today. It includes this project file with 5 different setups here on different things. So take a look. There's different methods to this pop attraction that can give you some differing results. So some of them work kind of well. I think this one maybe is the one that doesn't work all that well. Or no, this is the one that works the best in my opinion. So this is kind of the one that attracts the particles towards the surface of the object to where they're closest to. Some of them have some differences in how they're distributed, the points are. If you saw the setup that we're building right now, if I disable our wind here, I think we should get some, yeah, we're still getting that snapping through. Anyway, so we get some grouping that is kind of towards some clumping. So you run into that sometimes, and it can be kind of a little bit finicky to get rid of that. But so I got a few different setups here that go over different ways to kind of get rid of that, and take a look at all of them now, so you can kind of get some differing results here. So this exemplifies that as well. So we have a ton of clumping right here. So there's 4 different ways that I've set up here to kind of get rid of that, and this is the method that I prefer the best. So I'm going to cover this in another video, but that'll be coming next week. Let's go ahead and jump back into our project. We'll be sharing this hip too. So the one that I'm showing right here is available on Patreon. So if you want to grab it on Patreon and go through all these different methods, then yeah, you can grab it on there. If this one turns out well, obviously, like I said, I'll make a video on this as well. I'll kind of break it down into a more simplified thing, because I've gone through some different issues here, just of my own stupidity. But it'll be a more condensed video, and the project file again will be available on Patreon for that as well. So let's jump back in here. Let's turn back on our pop wind. See if we're still getting that. This particle is kind of popping through. No, we're not. Okay, so not really going to worry about it too much then. And I actually, let's see, this kind of takes a little bit of time. So I'm going to crank down our amplitude here on this, I think. Try to speed this up a little bit. And I actually don't like that. So I'm going to turn that back up, and maybe I'll crank up the scale on this pop attract. That's not really giving me what I want. So I guess we'll just go with this, and I can change it later. Actually, that goes through pretty quick. So now I want to kind of create a fall off of particles transitioning to our second object. So this is the part where we experiment. So we're going to use a pop group, and we'll call this the transition group. Transition. Make sure that this is enabled, but we only want to do it for the bounding region. And let's do a sphere, I guess. Why not? Let's crank up our size a little bit. Should be good enough. And let's see. So our particles are all kind of in place by around frame 95. So we'll start with our keyframe there, and then let's move forward maybe a second or 30 frames, I should say. And let's move this over somewhere like that. And we should start, so we should have Let's see. Is this how I want to do this? So I want them to, once they're in that group, to stay in that group. So basically, I need to group these points, these particles here, and then have them stay in that group so they can transition. So let's see. What is the best way to go about this? Maybe I should use some vex for this. I think that's probably going to be the easiest thing. So we'll do a pop wrangle. And I only want to affect particles that are in this final pause group. So the ones that are have already hit this this pig head. And let me turn the grid back on here. So you can see where we're at. So we are at -1 and some change. So we're going to do, let's see, we'll do an if statement. So if at p, so if our position p dot x is less than -1, or no, we need to create a attribute. So we'll call this f at threshold, I guess, is equal to chf, and then let's see how we do this again. Let's say, I hate the way this looks. Let me just give it the name. I cannot remember how this works. So just the name. That's right. So let's do a threshold. Create our spare parameter there. So we'll do at threshold. So if it's less than the threshold, so we can animate that, then we want it to be included in a group. So we'll do I at group underscore, we'll call this, transition. That's what we're going to call it, transition, is equal to 1. So let's see, p dot x is greater than the threshold. We want it to be not greater than, but less than the threshold. Yeah, and then they're in the final pause group. So, or do we want it to be less than the threshold? No, we want it to be greater than the threshold. Yeah, we want it to be greater than the threshold because we're going to transition this from left to right. So we want the points of these are like 1.2, so we want, or -1.2. So if we move past that, we want to include them in the group. So at, let's see, I said at frame 95, we wrote like -1, and then we'll go to like frame 125. And let's turn our grid back on here. See where we're at, -3 and some change. So we'll do -3.3 should be fine. Keyframe that. And then we should have some points in this group, which we do. And another way we can check that is we can just set there at p dot x is equal to like 0. I think that should work. So they should start to pop over there, which they do. And that is good. So the one thing that we're gonna run into here is our pop one. So we may need to also disable that for the transition group here. So we know this is working, so we can go ahead and just get rid of that again. And then we want to do another pop attract. We're gonna copy, let's see. We're gonna need to make duplicates of these. So we'll call this goal distance 2. We're gonna basically just name all these number 2. And make sure we change that to 2. And then we also need, oh, I know why this was giving us issues before. We want this to be before our pop attract. Let's just take a look at that. So before, let's break this back out. So before, if we look at this, we have, if I turn off the pop wind, that's what it was. We have some particles that kind of snap through our object. So you see them moving past right there. They should be hitting that and stopping. I think that's due to this being after the pop attract, if I remember correctly. So, oh, no, still has that issue. Either way, we get rid of it once we add that wind in, so it's not a big deal. Let's see. So we need to take, oh no, that was what we just created. I'm an idiot. Let's leave that back below it. Let's see. So goal distance, we copy that one over, so we need to also copy this one over, and we want to set this one to final position 2 and goal distance 2. And we're going to run these back through our particle sim. Oh yeah, we want to set these goal prem 2, prem uv2. Just need to change all these over so they're updating the correct things, and then we want to bring in our our pop attract down here as well, and we want this to be, let's see, we only want these to be in the, not the final pause, but the threshold, or the transition group. And also, well, we'll cover that in a minute, but we want to come back into this wrangle as well, and we want to make sure that we have these third context geometry, because that's where our rubber toy is, and we want to set this not to 1 but to 2, because we want to access the rubber toy geometry. And I think that is all we need. Hopefully this gives us what we're looking for. We also need to change these, so final pause 2, prim uv2, and fingers crossed that this just works. No, because this is acting on here, I believe. Here, let's disable that. Let's see. We only want this working on the transition group. Yes. We only want this working on, all of these working on the transition group. And hopefully that gets us back to where we're at. So we're good there. Then they should start to transition. They're not transitioning correctly because we have this set to second context. We want this to be third context geometry, I believe. So let's take a look. Well, it's somewhat working. Not exactly how I anticipated, but let's see. I'm gonna turn off this pop when for now. So still not working exactly how I'm envisioning. Like I said, I have no idea if this is gonna work. We're just kind of working through like an R&D type thing. So let's see, this is final pause 1. I guess the issue is this. So we want them to work on, as they're getting pulled away, they're getting put back into that final position group, or outside of that final position group, which we don't want. So we also want to include the transition group in here, and we want to make this not work on the transition group, I believe. Hopefully. So let's enable this for all of them. And then lastly, the pop attract, not the transition group. So let's give it a shot now. Nope, still not working. Okay. Well, this might be just a wash. So let's see. That's fine. These are all working. Here, I'm gonna turn this pop one back on for a moment. See what this, okay, so it's still just being annihilated here by something. I don't know. Something's going on. Huh. Final pause. Okay, transition. That should be working. Give me just a second here. Okay, I don't know what's going on here. I don't know why this would not be working. Final pause. Okay, so we got our transition. Let's turn these back off. Okay, so whatever we just did is causing the issue here. So let's get rid of all this again, and let's walk this back. Oh, and then I pop attract as well. Maybe just smart to spawn this in another, or spawn another set of particles, or run this through a secondary sim. But I don't necessarily like that. I suppose we could. Suppose we could do that. So let's give this a shot. I'm gonna make a copy of this just in case we mess this all up. I'm gonna make a second copy. So let's take a look at this. I'm gonna go ahead and just delete out everything that I just did there out of this one. And then we should have our, Oh, well, that's interesting. Okay, then. Happy accidents. I'm not sure why this is all just changed. This should not be spawning on the first input. Did I? Oh, that's why. Okay, so I accidentally changed our first input there. Okay, so we have this, and by this point, we should have everything in our geometry. Should have everything transitioned to the transition group. So let's take this. Let's blast away everything. Except for the transition group. Or everything outside of the transition group. Yeah, okay, so now we can take that, plug that into our first input. We need this brought into our second input. And I'm gonna, do I need to clean this? So let's look at this. So we want to spawn from points. First context geometry, that should be working. Why? So we need to set this equal to, oh shoot, this ain't gonna work. Yeah, this ain't gonna work because I would need to do it on like frame 125, which works and then doesn't. So let's see. Let's do this differently then. Let's jump back into here. And let's go ahead, take our, we want to spawn from these particles. And we want to kill them, I think. So pop replicates, I guess. And let's do emitted from a point. Make sure that we're emitting from the points. And we want to do an impulse activation of 1. Only the transition group, I think. I need to plug that in. I'm dumb. Let's do a pop attract as well. And just set this to... let's see. We need to... Well, I guess we don't need a just born group. What am I looking for here? There we go. Okay, so pop replicate. That's what I'm looking for. So press play and getting more particles. That's not what I'm looking for either. Huh. What is the best way to do this? Like I said, this is R&D. This is kind of how this all goes, especially inside Houdini. You go and create something that you think is going to work, and it may fail catastrophically, which is kind of where we're at right now. So we need to take the particles. We want to spawn them because we need the particles to move. Huh. All right, let's walk this back. I'm not liking where I'm at. So let's see. So we get to here, we get our particles to attract to the surface. We only want to attract, let's drop down another pop attract here. So we only want to attract the particles that are in that just born group, or that transition group. So but we also need to deactivate them for the other group. When you make a group, how does Houdini define the contents particle ID numbers? It depends on what parameter you set up. I guess at least I think that's the question you're asking. So the group is going to be based upon, like, so if I, like up here with this pop wrangle, so I'm creating a group with this, and I'm only including the points that are past a certain point in X. So if I had set the threshold equal to 0, any points that are negative in the X are going to be in that group. So like everything in this, once it gets to this point, everything, I bring our grid back up, the origin is right here. So if I were to set the threshold to be 0, everything this way of the origin is going to be included in that group. Does that answer your question? Hopefully that is what you're looking for. Will the stream be saved on the channel? Yeah, I think so. I'm, like I said, I've never streamed on YouTube before. I think I have it set up to where it will automatically save this, but I'm not 100% sure. And we've ran into a lot of issues in the stream, so it's kind of the R&D process. I guess it's good for learning, but if I work out an effect that works well, then I'll make a more condensed version of it into a YouTube video. Does that mean the particles are part of multiple groups at different times of the simulation? Yes, they absolutely can be. A group is simply just a 0 or 1 telling you whether it's in or out of that group. 0 if it's not, 1 if it is. So it can be a part of in any number of groups that you want. A group is simply, if we take a look at the geometry spreadsheet, if we scroll all the way over to the right here, this is where our groups are at. So a group is simply just an attribute that's a 0 or a 1 value. So there can be any number of groups on a point. And I mean, technically, let's see. Yeah, technically if you think about it, if you have any sort of value, any attribute that is a 0 or a 1 on a point, that's technically a group. It's not going to show up as a group, but it's in the same sense it's a group because it's the same 0 or 1. But any attributes will have to have this group colon before the name. In order for them to show up in like this like group list. But in that same vein, you can use an attribute to define a group as well. So if I wanted to, so here, let's just show you here. If I drop down a grid, take a look at this grid, and I drop down a color node. So we can just do @cd, or not cd. Here, let's change the color. So we'll do @p.x. P.x is greater than 0. Let's see, is that going to work? cd.r. No, it's not wanting to work. So let's see. Why are you not working? Should be working. Group type. Oh, group type points. That's what. Okay, so p dot. I guess it doesn't have to have the x. P dot x is greater than 0. So this is a Boolean statement. It either is greater than 0 or it's not greater than 0, right? And let me just turn back on the grid and do that. So if I look here, so the grid, so this is the origin line, right? So if it is greater than 0, these points are going to be colored red. This is simply a Boolean statement. It's either greater than 0 in the x direction or it's not greater than 0. So it's a 0 or a 1 value. So this is the same as a group. Any sort of Boolean statement. A Boolean statement is just a true or false, or otherwise known as a 0 to 1, or a 0 or a 1. So it's essentially the same thing as creating a group. Hopefully that answers all your questions there. But back to this effect here. So we need to take these points, and we only want to include the ones that are in this group. So, or the only ones that are in the transition group we want to have move. But we also want this attract to not affect we want the attract not to affect the particles that are still moving. Or we want this initial attract to not affect the ones that are in the transition group. I'm just kind of thinking out loud right now. Kind of think my way through the issues that we're having, because I initially created all these, if you missed it, created this transition group and tried to move the particles based off of that, and then it ended up not working just because of the forces were acting on each other. So how are we going to get around this? So we got our transition group. Particles start to get into that, and then we want to attract them. So let's crank that up. So they're still getting pulled back. So maybe let's break this down into just the simplest form to kind of try to figure this out. So let's take our initial sim here, our initial setup, I mean. And actually, let me just duplicate this, and we can just delete everything else. So I'm going to get rid of all of this. Literally only want, or actually I don't want to get rid of that last wrangle. Oh, I'm going to need more than that. Okay. So I need that. I don't want that for now, and I guess I kind of need that. So we want a pop collision detect. Just bring this back. Set that to the second context geometry, and we should be good to go. Once I hit this stop, we don't need our hits colored, so get rid of that. And whatever, that's good enough. So once we have that, we need our pop attract. So we're working off of, let's see, our final pause group there. We only want the transition particles. Let's continue to press play here. So we're getting that mutual attraction here, which we need to get rid of. So we need to take our pop attract, and we only want to group the ones that are not, or we only want to affect the ones that are not in that transition group. So I'm not really sure why this didn't work initially, because I think this should be working. So it's not. Huh. Let's bring back our geometry spreadsheet here. So they're in that transition group. Ooh, why are some of them in there and some of them not? All of them should be in that transition group by now. Huh. So they're all past that. But even so, it's still not working. So this works, but once it gets to this point, it's not working. This makes no sense to me. Weird. Because this should disable, so having a second group here, so where the particles that aren't in this transition group, that's what the exclamation point or exclamation point means. It should be excluding the particles that are in this group. So if they're not in this group, then they should be getting an attraction. But for some reason, we're still getting, we're still not getting any sort of attraction from our second pop attract. Which doesn't make sense to me. I don't think this is going to matter. Okay, so what in the world? Honestly, not sure why this isn't working. Huh. Let's see, I made the same rotating pig head fluid sim and I wanted particles to stop in pop collision check, but after stopping, they're not sticking, but continuing to move. I didn't solve that issue. Yeah, I'm getting the same sort of an issue, and I'm not really sure why. So this pop collision detect that I have right here should be stopping all the particles, right? If I just disable this. So I'm using the second context geometry, which is our pig head in this, and they're going through, kind of going through the pig head here. And I don't know why. I'm guessing this is using, the collision detect is using a surface and not a volume, which is why. I'm guessing it's just moving too fast in order for it to detect that hit, and it's just not working because of that. I'm assuming if you cranked up the sub steps, it would probably end up working. Try it out. It's going to really slow down the simulation. Yeah, so if you just crank up the sub steps, it ends up working, but I don't really like that because it makes the sim way slower. You can take the velocity of your particles, and you can, yes, increasing the substeps is how to get rid of it. But you can also take the velocity of your particles, and as they get closer, which is what we did before in the initial, in this subnet here, as they get closer to the surface, then you can multiply the velocity by like the velocity vector by like a value of 0.95 or something like that, and it'll slow that down. So you want the analytical way. I'm not sure what you mean by that. Yeah, I'm kind of stuck here. I'm not really sure why this isn't working. We should be able to move between these. I can't really spawn the particles. I can't really spawn new particles and have them move. I don't believe. And I don't know why. We shouldn't be having the issue of the particles being attracted by both attractors, because the groups should disable that. So like I said, I'm kind of at a loss of where I should be moving from here. It's kind of how things go in Houdini. Sometimes things work, sometimes things don't work, and sometimes you just have to like sleep on it, and maybe the solution will come to you. It's kind of late here for me. It's 11:30 at night, so starting to get a little bit tired. So that's probably playing an effect into my critical thinking skills here. But I'm really at a loss. Not sure where to go. So if we spawn new particles to pop replicate, I guess we'd have to kill the original particles. Let's just worry about that. Oh yeah, the pop replicate was an issue because they were, well, we weren't killing the original particle either. So let's create the point. We want to kill the original particles. We're going to set that impulse count to 1. And we want this to only be the transition group. So let's see what that does. So it's like these particles. They're like part of, like it's spawning them right away. And even though that doesn't make sense because they should be only points to replicate reference stream. Do I need the second? Yeah, no, that doesn't make any sense. They should only be getting replicated if they are in this transition group. We don't have like a blast node in here. We have a delete. I guess we have a delete. I don't really like that thought of that though. Yeah, I don't know. So that should only affect the transition group, but it's not. I guess, do we have, are they part of this transition group? No, they're not. There's nothing in this transition group right now, so they shouldn't be getting replicated. I'll dream the right answer tonight, maybe. I guess, I don't know. I'm at a loss right now. Is there anything you guys have questions about that you would you'd like to maybe go over? Give my mind a break from what we're working on here. You know, maybe mops is the answer. Mops could be the answer, I suppose. If you don't know what the mops are, it's the motion operators toolkit. But I don't have the pro version of mops. So that's where all the mops pop tools are at, is in that Mops Plus, which I don't have. Or am I missing something stupid that you guys are seeing with this pop replicate? Should this not be just replicating once they are in this transition group? Seems like that should be what's going on, but it's not. Maybe I take a break from this. I know that in my Discord, if you guys aren't part of my Discord, you should jump into the Discord. I think the link should be in the description, so you should be able to join there. Had a question in my Discord about creating boxes in a line that are kind of changing sizes based on the points. So maybe we take a look at that. Take a break from this. So we'll just go for that. If you guys have questions or that you have and would like answered, feel free to ask. So basically the question that was asked in the Discord was he wants to create a bunch of points. I don't like the way this is looking. Let's turn this back to light. So he wants to create a bunch of boxes with random sizes, and they kind of need to change based off of the spacing of the points. So we can take a jitter. Let's create. Oops. So I only want a jitter in one direction. This is going to give us a random distribution of where this is at. Or the points. I guess this kind of doesn't work to what I was thinking. So I was originally thinking he wants the boxes to scale in between these points and have them kind of touch, I believe. Originally I was thinking to create a point in between, the halfway point between each point, but I don't think that's going to work either. I don't know. I don't want to tackle that. It's too much for my tired brain right now. I guess a part of you guys probably weren't here for the start of the stream, which was I was just kind of starting to build out the effect with the attraction to the surface. I've got this is a project file that's available on Patreon. I've got a video that went up today based off of this effect, and this is kind of the setup that I think looks the best. This is attracting towards the closest point on the surface. So we can go over that. Let's see what you said. It's somewhat complicated, but let's say you had a stream of particles following a curve and you wanted to replicate a sniff force. I don't know what you mean by that. A force that only affects a portion of the particle stream. Okay. What portion of the particle stream? Isn't there a pop net? Is there not a curve? Pop curve force. Never actually used this node. Give it a shot. Let's drop a sphere down. Okay, as if a dog sniffed and organically moved just the end of the stream. So, particles following a curve force. I'm having a hard time picturing what you're asking there. So you want the particles to move along a curve, and then you want a force to kind of pull them away, but only a part of them does it matter where in that? Because if they're at the end of the stream, I don't know. Like if I apply a force to a pop net, all particles are affected. Go on. Well, just the particles at the end of the curve. So you need like you just need like a group with an attraction, like a pop attract. Suddenly, yeah, with like a pop attract. Here, I'll try and replicate kind of what I think you mean somewhat. Let's call this curve. And actually, let's just move this over there. And sure, whatever. So we'll set our curve force. Curve. So this is kind of what we're looking for. It's maybe too many particles. Let's drop this down to 1,000. And follow scale. I think we can. Maybe it's suction scale. This moves it up more. Let's crank the suction scale up. See if that makes particles move faster. I haven't actually used this node, so it's kind of making it move faster. So maybe let's just, for simplicity's sake here, let's well, I guess we'll just have to crank that up. Scent wafting in and then being sniffed for the dog for context. Yeah, I kind of get what you're saying. So we could do this. Let's do like a pop group again. All right. Does scene scale affect pop forces like curve force? I believe so. I don't know that for sure, but I believe so. It definitely affects other simulations. So Houdini is dependent on scene scale, especially for like RBD sims. Someone actually asked me about that recently in Discord. The scene scale is very important for things like RBD sims because the gravity and everything is based upon like real world scale. So if you've got an RBD sim where a building is falling apart and your building scale is like the size of a terrain in Houdini, it's gonna not work properly. You need to scale it down to real world scale, which one unit in Houdini is 1 meter, I believe. So keep that in mind as you're doing your sims. So this pop group here, let's click this enable. And we want to keep it in the bounding region. Let's do a bounding sphere. And why I should be getting a visualization here. I don't know why I'm not with the pop group, but yeah, this doesn't make sense why I'm not getting a Oh, because I have no group name. Let's call this, I don't know, sniff group. Yeah. Okay, so now we have our visualization there. So let's crank up the size here, and maybe, like, well, again, we're going to run into the issue of them moving outside the group. Let's see. Prism. What does the preserve group do? Each frame new particles will be added to the group by this pop, otherwise the group is reset each frame. Okay, so I think this is actually what we're looking for. Yeah, I think this is what we're looking for. I think we need the preserve group on. So let's move this up, and then we could do another pop attract. But we only want to attract the particles that are in that sniff group. And just for simplicity's sake, let's move this goal, I don't know, over to like 2. And just crank up that scale. So I think this should kind of do what you're looking for now. Or not. Let's see. Are they being included in that group? Let's find out. Yeah, they're being included in that group. I guess we need to disable that for the sniff group probably. Is everything being included in that group? Okay, yeah, that's the issue. Okay, so we just want in that. Okay. All right, so, and that may be the problem with our other thing too. So now you can see somewhat of what's happening here. So essentially, I think this is kind of what you're looking for. The particles are being moved along this curve that we have set, and then they're getting inside that group, and then they're being pulled away by the pop attract. Is that kind of what you're looking for? I don't know. Is your name supposed to be Shibby? Is that what it is? I don't want to butcher your name. So they should be following along that curve group. They are coming towards this goal. Let's move this up a little bit as well. Yes, it is. Yes, it is. That's how your name's supposed to be said, or that is the answer to your question. Looks like they're still trying to follow this curve somewhat, which I don't really know why. Or maybe they're inheriting the velocity. Oh, well, it's both. Okay. Yeah, I don't know. I guess that's kind of what you're looking for. This would be more easily exemplified by just using another pop attract probably. So if we just move this like up to like, I don't know, 5. Why are you not giving me the sniff group? Oh, because I need to reset. So anything outside this sniff group, particles should spawn, they should go upwards, and then they're going to get pulled to the side because they are now inside of that group. But yeah, that's kind of how you go about doing that. Let's jump back into this, not that. Oh, I guess this is my project file from the other thing. Let's take a look back at this. You guys have any other questions? So groups being maintained. Yeah, I don't know. this is really throwing me for a loop as far as getting these particles to move between objects. Usually when I go to R&D stuff, I don't know how you guys actually go about working, but I typically will go through, start creating a setup, and at some point in time, eventually I kind of get stuck, or at least when I think about making a setup, I'll come up with it in my head, and then I kind of think about how I would make it and work myself through the problems that I might run into. So sometimes I have to come back to it. So I'll probably be thinking about this setup for a few days. I'll definitely be thinking about it when I go to sleep tonight. See kind of how I want to go about fixing this, because I'm not sure. We could spawn another set of particles. Oh, I'm dumb. Yeah, I'm dumb. Okay, I know how to do this. I know how to do this for sure. Let's move this back. Whoops. Let's get back on track, I guess. Oh, God dang it. Okay. There we go. All right, so let me jump back in here. Let me set this back to dark. I just had a thought. I think I know how to do this now. So, and let's just get rid of that. Actually, let's jump into this pop net here. I just want. Let's see. I don't need this pop attract. I don't even need this transition group. Do I want to keep this? I think I want to keep this, because I'm going to make a second one of these. Did I include this? Let's just clear all this out, just so I don't confuse anybody or myself later on down the road. So essentially what I was trying to do was create this transition group and have them transition between the two, which would work if I wasn't stupid, probably. But I'm too stupid to do it all in one simulation. So what I'm gonna do here is I'm gonna take a blast node, and I am going to blast away every single point that is not in the final pause group. And they were all kind of in that spot on frame 95. That's where I started my initial simulation, my other simulation. So I'm going to make a copy of this. I'm going to pipe in our blast into that first input. And let's set our display flag there. And I want to set this equal to frame 95. And I'm going to name this final pause 2, because the ones that we're bringing in, I think, should have the same attributes and groups. So we'll just do this. Final pause 2. So nothing's going to happen until frame 95, or nothing's going to happen at all, because I need to set this to points. And am I going to get 4 million friggin' points here? No. Okay, I get 1, right? I should get 1 point per. Yeah, okay, so I got 3,000 points, which is what we started with. So I now need to take all of these. I can update my goal prims because I don't care about them. I don't need to change them. But I need to change the geometry that we're working with to our second context geometry, or our third context geometry, which is the what's it called? The rubber toy geometry that we set up there. And our pop attract needs to also be our third context geometry. And now, hopefully, fingers crossed, we get some movement towards that, at least, that are not affected. So I guess now we're part of the way there, but the particles are not moving exactly how I want them to, or to where I want them to. They're probably, let's get real basic with this and go back to this. Let's go ahead and change this, because I think even if we take a look at this blast node, yeah, we still have all of these attributes. So actually, if we get rid of them all, it might just fix it. So I'm just gonna remove everything here except for the attributes. And let's just try and turn these back on and see if this works. So frame 95, they should spawn. And no, it still doesn't work. Okay. Well, it was worth a shot. There was one. Oh, no, never mind. All right, so let's get real basic with this then, and let's set the pop attract to that random value. Let's just actually delete all of this. Set this back to pass through, just to bring that all back to the way it was. And let's do a floor with a fit 01 and a random at pt num. You want to set this from 0 to the detail attribute of the second input, or the third input, I should say. Third input. We called this originally in the start of the video or stream. We called it endpoint or inprem. Number of prems? I don't know. We'll take a look. Let me pop this back out because the text is too big. Inprem, and then should be just 1, I think. What are you not liking? Syntax error. I did. Oh, I forgot to do that. There we go. So let's see what this gives us. Hopefully this will give us something interesting. Gold prem. All right, let's do something else here. Let's take this pop angle. I'm gonna copy all of this. I'm gonna call this we're just gonna create a new integer, and we're gonna see what the geometry spreadsheet gives us. So I'll just call this test for now. We'll set that equal to what we just created in this pop attract, and then we're going to pipe that into here. So let's press play and let's see where we end up with. So we're looking for that test, or our test thing. Okay, so here's our issue. We're getting it's not creating a random value. It's just setting it to 0. Forfeit random pt num 0. Okay, so this may be the issue. No, inprem details. So maybe it just doesn't like this. So let's do this. Detail. Is this gonna allow me to do this? No, it's not. I thought. No. Geometry. Oh, I'm dumb. I need to do the bindings. Let's just set input 1 to our third context geometry. Then we can just set this equal to 1. And if we reset that, hopefully we have a random value in the test. And we don't. We still don't. What is this error that you're giving me? 3,000 points. All right, let's just raw run this value, and instead of trying to make this procedural, how many prims does our test geometry have, or our rubber toy have? 12,873. Okay. So we'll run this between those numbers. And do I have a random freaking value now? Hey, I got a random value. So let's press play. Let's see what happens. Oh, there we go. Yeah, that's what I was looking for. Multiple. I don't know why it wasn't letting me do that. So I should be able to access. I'm starting to get tired, so I'm probably just making an error. But like this should be, I should be able to do the detail, right? And then, is it this? I should be able to do like that, and it should start to pop up, but it doesn't. I don't know why. Because I should be able to go up and I should be able to go up in like the hierarchy or whatever you want to call it. But it's not working. But as you see, we start to get exactly kind of what we're looking for. I'll have to work through that and figure out why I'm being dumb. But we should be able to now. Well, I kind of need this goal distance and stuff. So I don't know why these weren't working. Let me re-enable these. Let's see what we're getting. So we should be getting different values in the final pause and stuff. Let's see, final pause, final. Okay, so I'm not getting a integer in this final pause. Maybe I'll just set this to a random value instead of, because if I'm calculating the distance, the closest primitive, then then our issue would be we would just have them stick to one side of our secondary object. So let's take the wrangle that we got here. Let's take this and then let's pipe this into here. Bam. And then we need to set goal distance. I guess we're never UV. I guess we could just pipe in a vector to this. 0, 0, 0. And we could call this, we could reference our final pause for this. It's not liking that, not liking that one bit. Okay, so maybe I'll just set that. What did I have here for this? My goal param UV. Oh, it's still not liking that. Integer vector float. What? Oh. Helps if I spell this right. There we go. Oh god, that threw errors for all this. What? Invalid group. What? I don't have a group. Because I need to calculate the distance. Because I don't want to... Here, like watch. Am I still getting an error here? Valid group. I don't know what you mean by that. Oh, it's because I'm in the first frame. Duh. So it should pop up here. Probably. Alright, let's turn these back on and see if this works. First time catching the stream. Hey man, it's the first time I'm streaming. On YouTube at least. And first time I'm streaming Houdini. So welcome. Alright, I got 2 of these. That's part of an issue here. I've got 3 of these. What the heck am I doing? Oh my god. Okay. Let's see. You know, Robotoy is out of frame. Yeah. Well, actually, it's not. I don't. Yeah. Oh, maybe it is. Yeah. I'm not too concerned about where it's at right now. They're all flying past that, and that's what I'm working on fixing at the moment. Sorry if I'm not explaining that very well. We need to grab something from this original popnet here. Let's take, we want this and this, and we want to bring those in here. Yeah, I don't usually have time to really stream much between making videos and spending time with my family and everything. So unfortunately, I don't get to do it all that much, even though I would like to. Okay, so our issue here is we're referencing, oh wait, no, I'm not referencing anything in these. But I am in here. Okay, so when I copy these over, it didn't bring in our third context geometry. Needs to be, our input 2 needs to be, no, our input 3 needs to be third context geometry. The stream hasn't gone particularly well in terms of what I wanted to happen. Just as far as like, I've ran into a lot of issues that I didn't foresee. I was kind of trying to think of what I wanted to stream on and like what kind of a topic I wanted to cover, and just kind of came up with this at the like right before I started. But hey, we're kind of at the final result. We've officially kind of done what we did. Once or twice a week. Yeah, so the problem, I would love to do it once or twice a week. The problem that I run into is that it's hard to balance time because Houdini is and making videos and stuff. It's something I just do for fun. This is all my like 3D art stuff is just something that I do for fun. I make a little bit of money off of it, obviously through Patreon and ad revenue on YouTube, but that's mostly just to pay for the licenses that I have throughout the year. And I have a full-time job that I do, so I don't have a ton of time between that, and I've got a 9-month-old baby that I gotta wash bottles for and stuff, so that he can eat and everything. But yeah, we're pretty much at our effect here. All we need to do is merge a couple of things together. We need to make this final pause, get rid of that, and drop down a merge. And we should kind of have the effect that we're looking for. So, oh, well, apparently not. That did not work. What the heck happened? Oh, we're getting rid of everything. But they should be respawning. Interesting. Well, that was not expected. Let me just merge these two. Okay, well, not that. Huh. Why? Oh, because they're not. Okay, I see. So the issue is I'm spawning them on frame 95, and they're hitting inside that group before frame 95. Sorry, I went a little quiet there for a second. So the last thing that I need to do would be to solve that. How do I want to solve that? Do a switch node. I think we could do a switch node. So we'll do that. And we could simply set this to input zero on frame 94 and input 1 on frame 95. It's going to give me an error. Just pop in a null. Should be good. Right? Kinda. Let's take a look back at that. Huh. How many points did I have in that first simulation? I had the same amount of points, did I not? 3,000. Mission, all points. Guess you just need to do all points? Yeah, all points. Okay. That should solve our issue there. So I'll move through. Yep. And then now they kind of move over. Now we do have that issue of them just passing through, and we got a couple straggler points, but that's kind of the effect. Why are these points flying back and forth though? I bet you they don't have primitives. What point numbers are these? 543 is one of them. Let's just look at that one. So 543. I bet you if we look at the, oh no. Huh. I don't know why. Because what I was expecting was this final pause would be like 0 or something. But it's not. So I don't know. I don't know why they're just kind of flying all off into space. But we have the gist of the effect, and that's probably something that I can figure out on my own time. Outside of the stream, probably. But yeah, this is kind of the effect that we were going for at the start of the stream, so we were somewhat successful, even though it took us quite some time to get there. It should not have taken me nearly this long. And I definitely made a lot of silly mistakes when I first started. So we wanted to let's set this to final pause 2. If you don't have that, so maybe we get some, yeah. So that's a little bit better. And then we want we need to set that group, not final pause, but final pause 2. There we go. And that looks a little bit better, I think, or it should look a little bit better. Let's pop out of here. Yeah. So we still get a couple of little stragglers there. Not sure why there's stragglers like that. Perhaps if we increase the strength of our attraction. We may get them pulled or just rein back in. Nope. It's got to be something to do with their, yeah, there's something wrong with those points and what they're being attracted to. So let's take a look. Let's see if we can figure this out real quick. Okay, the problem is if we have 100 targets and target switches randomly, that's not a method. Yeah, you're correct. 2402. Let's take a look at this particle. 2402 is what it was, right? 402. Yeah, so I'm not really sure why. I'm not really sure why it's not getting brought in, because it should be. it's not included. It's in final pause 1, but it's not in final pause 2. Yeah, I don't know. Those are threshold 0. Maybe that's why. The rest of these are -3. Threshold. Where did I put that threshold at? Threshold 0? Huh. Am I using that anywhere? I don't even know if I'm using, I don't think I am using that anywhere, am I? Because we just spawned them. Call this, yeah, no, we're not. I don't know, a little weird. Interesting. Which simulation tax the machine a lot between particles and vellum class sims, and also those simulations, are they done on the RAM or the CPU? Are you asking which tax the machine the most between particles and vellum cloth? As far as what they're done on, they're stored in the RAM. The information is going to be stored in the RAM. The calculation's actually going to be done on the CPU with both of those. I don't think either one of those have GPU acceleration. So they can't run on, they're not GPU solvers, so they'd run on the CPU. And then the information's stored on the RAM. So, or stored in the RAM, unless you're caching it to disk. But as far as which one is more taxing, I'd say it depends. Depends on how many particles you got, and it depends on what you're doing with your class sim. Simple class sims would obviously take less computational power than something with like 50 million particles, but something with like 5 particles would take less than something with a class sim. Yeah, CPU for speed. RAM is going to limit the size of your simulation, and so you see this blue bar down here on your timeline. That's all what's stored inside your RAM. So if I come into our PopNet here and I come to our cache and I set our cache memory to like 500, it's gonna fill up here. At least I think it will. Maybe not. Maybe like 50. So it should fill up. This may not take very much RAM. That's why it's just not filling up. Yeah, whatever. But if I were to, I can just drop down another one. If I drop down another PopNet here, and I take a look at this. If I spawn like 500,000 particles, you see that this is going to fill up. And this should start to, yeah, so you see right there, it starts to, the blue bar starts to come along. And that means anything back here outside of this blue bar is no longer stored in RAM. You don't have enough RAM set on your cache here. But if I set this up to 50 gigs, now I can get a lot further before it starts to come along. I might even get through the whole sim. So I've got a lot of RAM. So things that take up a lot of RAM or a lot of disk space are like volumes. Volumes will be very computationally heavy, as well as fluid sims. Fluid sims are notoriously slow and take up a asinine amount of space in both RAM and cache space. So like a fluid sim, like I've seen, that's part of the reason I don't really mess with fluid sims very much, is because you can have like a simple like just a few seconds long simulation, and it'll be like, I don't know, 50 gigabytes or something ridiculous. 100 gigabytes, 500 gigabytes. It all depends on because if I look at these pop nets too, if I just drop in on a null for ease here, I look at our geometry spreadsheet, we have all these attributes, right? So these attributes are going to play a part in how much disk space and RAM it takes up as well, because this is all information that's getting pumped into your RAM. So we've got, at frame 235, we've got, half a million particles or whatever, 5 million particles, whatever this is. Understand. So how many RAM you have, because I'm running 32 gigabytes, so I feel like simulations are slow. So your simulations are going to be dependent upon your a couple of things. What type of simulation it is, your CPU or your GPU, depending on what you're running. So like the sparse Pyro solvers are going to run on your GPU, and then they'll run a little bit faster, but they'll fill up their VRAM. They don't have as much VRAM available. On my machine, I have 128 gigabytes of RAM, so I have the ability to crank through quite a bit of information into my RAM. So hopefully that answers your question. What's your name? Rahul Rai. Thank you. Took us quite a while to get to this simple little setup. What should have been rather simple, but eventually kind of got there. So made quite a few at the start of the stream. Hopefully no one was paying attention and didn't catch my dumb mistakes with just my thoughts on the detail attributes and stuff. Stupid mistakes that I shouldn't have been making. Thanks for the insight. Yeah, no problem, man. Does anybody else have any questions? This is kind of the end goal of what I was going for. Somewhat, at least. I've got a couple stray particles here, but this is kind of what I was looking for. And you could randomize. I guess you could randomize what object you're trying to go through. Because your goal prim. I guess so. DJ, you said something about if you have multiple targets and the target switches randomly. Maybe. I mean, you could probably, so it's all procedural-ish, right? So what we set up here, I mean, if you changed this, at least this fit to be automatic and procedural, if you did that, then you could set up a switch for the first and second inputs here. And then you could kind of change based off of that. You can probably, there's no doubt in my mind that you can get this to run off of one popnet. It's just getting that to work for whatever reason in my brain just wasn't working. So that's the reason I went through with 2 popnets. But I have little doubt that you can get this to work with just one. And I'll probably figure that out at some point. I just, like I said, wasn't working in my brain tonight. So if you did have it all set up in one, then you could have multiple targets set up in a switch node, and you could randomly switch between those two. And as long as you had the fit range set up properly, so it's automatically detecting the detail attribute of the second input, then you could have it moving between objects. They would just automatically move. I'm sure I can get this. I'm sure I can figure that out. Final pause. Because the final position, our final position is dependent upon dependent upon our inputs. So if we changed the inputs, yeah, it's got to work. Yeah, the switch would be the key, and the switch would only work. You'd have to have it set up in one popnet. Only one input because target is only one. Yes and no. I'm trying to think. So we could, if you want to randomly, I mean, I don't know. You could switch is only one input. Yeah. You could set it up. There's a way. I'm just going to say that. How about that? There's a way. One particle is always flying to the current target. Unless it's not. Unless you set it up to work based off of a group. So they hit these targets and they're not allowed to move in this simulation until after they're in this group, until they've reached their final destination of the first thing. And here we're getting somewhat of what I was talking about as far as particles moving towards the closest point on the geometry. And I thought I did the same thing here. So on the initial simulation here, they're not moving towards the closest point on our pig head. This is what that looks like. This is what that looks like. If I press play now, you can see they're attracted towards the ears, and kind of towards the nose is where they kind of fill in. So those are kind of the extremities of the object. So you can see that this shape of this particle shape we have right here is vastly different from what we have right here. They're more focused around here. I'm not exactly sure what I did differently. I thought I kind of did the same thing. If you want to look at what this is what did I do here? So pop attract, I just have a collision attract. I guess I'm setting that equal to my goal prim. So they're, let's just rebuild this, I guess, real quick. I'll show you. What did I do in here? Actually, why don't I just do it in this? So popnet. Like I said, I am going to cover this in another video. It'll be the video that comes out. One of the videos that comes out next week. I'll probably do a couple. Let's just rebuild this real quick. This will probably be the last thing, and then I'm gonna probably hop off for the night, go to get some sleep. So we'll do $ff is equals to 1. We can create like 3,000 points again. Set our pop attract. Oops, pop attract. Let's get our collision detect. Second context geometry. I want to color those hits. Let's make them stop. And you need our pop wrangle. And in this wrangle, we want to create a couple of integers, or an integer float and a vector. So I at my goal prim. We'll do f at goal distance, and then v at my goal prim uv. And then we can do integer goal prim. And actually, well, yeah, this doesn't really matter. So This is goal prim is what if we set this to surface points and use our second context geometry. So our primitive is called the goal prim. That's the name of that. So just for uniformity's sake, I'm gonna keep it the same. But the pastor doesn't really like it if you keep it the same name. So I'm gonna use the different name. Or I'm gonna use the goal prim, I guess, that we have. So we'll do floor. So we create an integer, and then we'll do our x, y, z distance function off of our pig input, which we need to set as the second input. It's our second context geometry. And then we'll do at p, and then at my goal prim, and then at my goal prim uv. And then f at goal distance, and we don't actually need this right now, but just because I want to. We'll just copy this and paste that as the same thing here. And what did I do wrong? No matching function. X, Y, Z distance, what do you mean? Oh, sorry. I gotta spell things correctly. That helps. My goal prim. There we go. And then we can set our pop attract, use this vex expression. We'll select our pass-through option, and we'll call this I at my goal prim. If I take a look at this, you're gonna see that hopefully, yeah, they all go towards kind of the closest point on the geometry here, which ends up being kind of the ears and the kind of extremities of the object for the most part. So the only thing that's left to get something that looks not like garbage, where it's just clumping all these points together, is to drop down a pop wind, and we can crank up the amplitude and whatever. And we need to increase the attraction. And actually, we want to, well, I don't know if it'll make them stop or not. Okay, so it does. So you can see that we kind of get things grouped a little bit towards the closest. Now it's going to depend on your settings for the the swirl size and everything, but they move kind of towards those extremities. You see that worked a lot better as far as keeping them towards the extremities, but varying the positions a little bit. So that's kind of how you get it to move towards the closest point. Like I said, the pop attract does not like it if you name the pass-through the same thing as this goal prim for whatever reason. At least in my past experiences. Let's see what it does. Because essentially we're setting it to, well, we're setting it to something similar, I guess. But yeah, that's why you end up with some of this grouping. And I don't know why it likes to do this, but it just kind of does. That's why you have to do some different methods to kind of break that up. And I've got in this project file, like I said, this project file is available on Patreon. It has these different setups in here. From the video today, it goes over 5 different methods for this. So if I take a look at some of these, you can see that's what we look like with one of them. So we're varying quite a bit on the final particle positions there. Again, we don't have very much clumping there or there. This one is the example that does. And then this last one is what essentially we just rebuilt, which is moving towards the closest position. So anyways, anybody, I'm going to probably hop off here. If anybody have any questions before we go, can probably answer something real quick if someone's got something. Otherwise, Otherwise, I'm probably going to hop off. I don't know if I can set this to automatically save. I thought I had it set up to do that. So hopefully it saves it. Let's see. I think it'll automatically save it. I don't know. Hopefully. If not, I guess this this knowledge is lost to the world, and you guys were all here. You can put pop interact to relax that grouping. Pop interact. Is that a node? I don't even know. Pop interact. I've never used this before. What does this node do? I've never used this before. Just stick it in there. See if it does. Doesn't look like it does. Probably doing something wrong. Like I said, I've never used this node before. Let's look it up real quick. Houdini pop interact. Pop interact applies force to particles based on their closest neighbors. Keep particles apart. Okay. Or to make them match velocities. This operation modifies the force attribute. How strongly the particles force each other's apart. Position force. Let's look. Maybe I have to put this. Yeah, I don't think it's going to like that because it's going to keep them from stopping. It should apart from each other. So yeah, it is. As I up this position force, like if I turn this off, go back to what we got. But as you up this, it stops particles from setting into their position. You'd have to crank up the sub steps again, probably. Something crazy. Which just slows things down. That's why I don't like to do that. One way to get around that is to kind of force the particles to slow down as they get closer to their final destination, which we went over earlier. So, no, I mean, it's a good idea. But just in this case, it doesn't work. I could see that being interesting in other situations, though. Like, that would be something good. I would say that'd probably be good for, like, packing objects, I think. Maybe, I guess. I don't know. Inner radius interaction of full strength. Yeah. Yeah, probably would be something good for packing objects. But in this case, it just stops them from getting to their thing. But hey, at least we got to this final setup, even though it took us quite a bit of time. Shouldn't have. But we got a nice little transition there from one particle position to the other. I'm gonna kind of go over this more on my own, probably off stream and not tonight, but off stream, and see if I can refine this a little bit, because this is kind of a cool effect. I like the little transition there. Something that's kind of cool and probably can be done in one pop net. So I'll take a look into that more and try to get rid of these little stragglers as well. So I don't know why that's happening. Doesn't make any sense to me. their target position is not where they're going towards, so it's a little weird. You could just cull them, I guess, if you knew what particles they were. But anyways, hopefully you guys enjoyed the stream. It is late, so I'm gonna hop off and get some sleep. And I may jump on tomorrow morning. I don't have anything going on before I go to work, so I might have some time tomorrow morning to hop on the stream. Maybe I'll look more into this effect in one more clean setup tomorrow morning. But we'll see how I feel. Thank you guys for hanging out with me and going through the shortcomings of my tired brain, but we got there eventually. So cool little effect that we created. Like I said, I'll look more into it, and maybe you'll see a video on it here in the coming days. But as I said a couple times throughout the stream here, the project file for this is available on Patreon. This is from the video that I posted today on how to track particles to the surface of other objects. So if you're interested in grabbing the project file, you can go through that. That was just a theory behind it, like the theory of how it all works. And then I'll have another video that goes up here in the next few days, probably next week, that kind of goes into more of this type of a setup. Well, I'll recreate this and explain this a little bit more. So as well as probably this one that doesn't have that nice even breakup of where the particles are at, and has this clumping. So yeah, you guys kind of got that before that video comes out. So that's the plan. And then if you guys are wanting to learn anything, is there anything that you guys would like to learn, feel free to hop into my Discord and let me know if there's anything that you guys have questions on. That link should be in the description of all my videos, as well as hopefully in the description of this live stream. So if you guys want to learn something, if you have any questions on anything, feel free to hop in there and shoot them my way, and I may end up covering them. And if not, I try to answer as many questions as I can in there. So feel free to ask away. There's a couple other people in there that are pretty active as well and answer some questions. A bunch of people ask questions, so feel free to do that. But anyways, like I said, I am gonna hop off for the night. Thank you guys for hanging out with me. We'll see about tomorrow morning, so keep your eye out for that. If I'm not too tired and I feel up to it, then I'll probably hop back on and stream for a little bit in the morning. So anyways, thank you guys for watching. If you guys are just hanging in for the first time, I do a bunch of stuff on Houdini, and if you want to learn more about it, I got a bunch of other videos on my channel that go over how to do various different things, as well as some stuff with different render engines as well. So if you're interested in any of that, make sure to check those videos out. But thank you guys for hanging out tonight, and maybe I'll be able to do this more in the future. I'll see what I can do. But anyways, thank you guys for hanging out with me, and have a good night, guys.